Okay, guys, video 2 for chapter 18. Here we go. Should be fairly painless. So now we're going to start to talk about calculating an actual confidence interval. So the one thing, and we kind of have that idea because I showed you the form with statistic, plus or minus, and margin of error, but now we'll get into actually more how to do these calculations. So one thing that I do want to mention is you may hear this referred to as a one proportion Z interval. That's actually what we'll be looking for in the calculator. There is a way for us to do this in the calculator. I will show that to you, but I'm going to demo that in class, not on this video. So before we can calculate a confidence interval, whether we do it by hand or in a calculator, we absolutely have to make certain that our three conditions are met. So it's the same three conditions that we've been looking at with proportions: an independence assumption, that's your 10% condition; sample size assumption, that's your large counts or success failure condition; and then it has to be random, okay? So I'm not going to go through them right now. You know how to do those. So here's that general form that we saw in the last video. Your statistic, we're going to be focusing right now on p-hat, or sample proportion, plus or minus this margin of error. So we talked about that being a certain amount of standard deviations away from your statistic, okay? Now we'll get more technical about where this where this margin of error is coming from. So the margin of error is found by taking a value which has to do with your confidence interval and multiplying by a standard deviation. So that value is going to be called a critical value, okay? And again, that critical value is found with your C% confidence interval. Okay, and to that we're going to multiply a standard deviation. The standard deviation we'll talk more about in a few slides away from that. Okay, but first let's focus in on our critical value. Okay, so if the normal condition is met, so we do have to check those conditions, we can use a normal curve. To find a level C confidence interval, we need to catch the central area C under the standard curve, normal curve, okay? So if I'm talking about a 95% confidence interval, okay, I'm talking about from here to here. But in order to find your critical value, that's going to be found by what z-score that you are at that confidence interval. Well, knowing what we know about how to read the normal distribution and how to find a z-score, we know that we would actually not do in between, but rather we would find where this would lie and where this would lie. So what we want to take into consideration is that to both sides is 2.5%. Okay? So to find my z-score, my critical value, I'm going to have to use my 2.5%. Okay? But knowing what we know about a curve, we know that there's a lower 2.5% and there's an upper 2.5%. And so we do have to be very careful. So we are going to find our Z critical score is put with a Z with an asterisk. That's our critical value, okay? And that is going to be found by taking your inverse norm, okay? Now you can inverse norm 2.5%, but you are going to get negative 1.96, okay? So you can realize that you're not going to be using a negative, okay? You have to use a positive. So you can either choose to ignore the negative, or you could inverse norm 1 minus 0.025, which would be 0.975. An inverse norm of 0.975 is going to give you your critical value of 1.96 which is what you need to use. So if I asked you for a critical value for a 90% confidence interval, we would inverse norm. So for an, actually let's do an 80%. So for an 80% confidence interval, we understand that there's 80% of the data here, okay? And to both sides, there's a lower 10% and there's an upper 10%, okay? So we want to inverse norm 0.10, okay? And that would give us our negative 1.28, so we would have to ignore the negative, okay? But we could have also just inverse norm 1 minus our point, our 0.1, so 0.9, okay? Which would have given you your positive 1.28 critical value. But again, realize that you are not using the negative, you always use the positive. Okay. So now we're going to talk about the idea of standard deviation. So now it is the standard deviation, but because we are not talking about the standard deviation of the population, we won't know the standard deviation of the population. We're using the standard deviation of a sampling distribution. Because we use the sampling distribution, we're going to be using p hat, not p. So what ends up happening is when we look at our standard deviation, okay, we're actually using our sampling proportion to find it. So we're not actually going to call it our standard deviation. We'll actually be calling it our standard error because we are using our statistic to estimate it. We can't call it a standard deviation because it's a standard deviation of a statistic estimated. We have to call it our standard error. However, it's found the same way. You're just using p hat in your formula instead of the p that you've been using. So, quick example, and then we'll be done with this video. So Mr. Vignolini's stats class took an SRS of a large container filled with beads. The class got 107 red beads and 144 white beads. So our proportion here is going to be 107 over the 251, so that's about 0.43, okay? So let's check quickly our conditions. So it's an SRS, so we're good with random, okay? We can check, our 10%. Well, is 107 10% of this container, this large container filled with beads? Well, I'm not really quite sure of how many beads are in this large container, but I think we can just assume that it is within 10%, okay? And then you check your large counts, and it is satisfied, okay? So let's go ahead and calculate and interpret this 90% confidence interval. Okay, so we know that we're talking about a 90% of our data here, okay? 5% this way and 5% this way, okay? Okay, so I'm going to find it by taking p hat and adding and subtracting our critical value and multiplying that by our standard error. Okay, so we're talking about our p hat is 0.43. Our critical value, you can find your critical value by inverse norming 0.05 or 1 minus it, okay? It's going to give you a Z critical score of 1.64, a very common one. 1.96 for your 95% is another very common one. So 1.64. Oops, I forgot my square root. The proportion for success was 0.43. For a fail is 0.57. and your sample size 251. Okay? And it's straight calculations, guys. So you will end up with a confidence interval. I'm going to write it down here. From 0.38 to 0.48. Okay? So what we can say is that we are 90% confident that the interval from 0.38 to 0.48 captures the true proportion of red beads in the large container. Let's take a look at Part B. Part B is saying that Mr. Vignolini claims that exactly half of the beads in the container are red. We need to use our results from Part A to comment on this claim. Okay, so confidence intervals give you a set of plausible values for the population proportion of red beads. So this would be considered a plausible range for your proportions to lie in. 0.5 is not in that interval. So he claims that half, so 0.5. 0.5 lies outside, okay? It lies outside of this interval. So because 0.5 is not contained in the interval, it is not a plausible value for P. We would have good reason to doubt Mr. Vignolini's claim. And now listen, it doesn't mean that it's not possible. It could be outside that interval, okay? It's just that this is a plausible range of values. So you would question his claim because it is outside there. It is not that his claim is not possible. And that's it for video 2.